Welcome to The Explainer. Today we are breaking down how a sow's own energy system might just be its greatest defense against one of the biggest threats out there in the swine industry, African swine fever. We're going to explore why metabolic health is really the front line in a battle that is all about energy.
Okay, let's just dive right into this idea. When a disease like African swine fever hits, it is not just a battle of cells. It is a massive, and I mean massive, drain on that sow's energy reserves. You see, immune cells need a huge amount of fuel just to activate, multiply, and actually fight off an infection.
And this, right here, is the critical question. Because putting up an effective immune response takes an enormous amount of metabolic fuel. And that energy demand, it often comes at the expense of everything else. The sow's own health, her milk production, and even the survival of her litter.
So to really get this, let's first understand the battlefield. We're calling it the ASF energy crisis. It's a crisis that happens at a cellular level, where the demand for energy to fight the disease just completely outstrips the supply, and that puts the whole system at risk.
The key concept we need to talk about here is bioenergy. Think of it like cash. It's the real, usable currency that a sow's body spends to power absolutely everything. An ASF infection doesn't just ask for a little loan. It tries to bankrupt the entire system, demanding every last bit of bioenergy for the fight.
So let's start with a really crucial baseline number. Research is showing that right now, in a typical herd, about 30% of sows already have a pretty significant problem with their glucose metabolism. So they're essentially starting this energy war with a handicap before the first shot is even fired.
All right, so if that's the problem, how do we fix it? Well, to get to the solution, we first need to understand the science. But don't worry, let's simplify it with a handy analogy we'll call the metabolic engine. I want you to imagine that every single one of a sow's cells is a tiny little house, and every house needs heat, or energy, just to function. Well, the fireplace inside that house, the part that's actually generating all the heat, that's the mitochondrion.
Now, in a healthy, metabolically efficient sow, the process is simple and it's really effective. Fuel, in the form of these glucose logs, gets delivered and burned cleanly. This produces all the ATP energy the house needs for growth, for milk production, and for a strong immune system.
But what happens when that fireplace is broken? Well, as you can probably guess, an inefficient system is leaky. It wastes fuel, it creates all this damaging smoke in the form of inflammation, and it leaves the sow in this constant energy deficit, struggling just to cope with normal stressors like farrowing, let alone a major disease. So, if the engine is broken, how do you fix it? You don't just keep piling in more logs, right? No, you call in a maintenance crew. And this brings us to the solution presented in the source materials, a product called Prosea. You can think of Prosea as a specialized repair team for the cell's fireplace. It isn't more fuel, it's a tool to make the engine run better. It uses this really unique combination of seaweed extracts and a highly bioavailable mineral complex to actually repair the metabolic machinery.
Prosea works in 3 key ways. First, it calms down all that wasteful smoke from inflammation. Second, it directly helps repair the energy conversion process, making sure glucose becomes usable ATP. And third, it improves how that energy gets distributed to all the critical tissues.
Okay, that's the science, but what about the results on the farm? I mean, does fixing the engine actually lead to better output? Let's take a look at what the trials show. So looking across 8 different studies, covering more than 5,000 sows, the data is remarkably consistent. Sows with a more efficient metabolic engine weaned, on average, 0.65 more piglets per litter, and that's a direct indicator that they have more energy available for things like lactation and litter care. And if we drill down a little deeper, a detailed university study from Dankuk University in South Korea really confirms these gains, and it gives us even more detail. Sows that were fed Prosea gained weaned over a full extra piglet, their farrowing time was 25 minutes shorter, and they produced heavier piglets at weaning. This is just a clear sign of improved energy distribution.
Okay, but what about in the real world? On a commercial farm, under local conditions? Well, a field trial in the Philippines showed results that were just as powerful. A huge 17-point jump in the farrowing rate, and over 1 extra piglet born live per litter. This shows the whole concept works outside of a controlled university setting, delivering real proof of a more robust, energy-efficient herd.
So we've seen these really impressive production results, but let's bring this all the way back to our original threat, ASF. how does weaning more piglets connect to fighting a virus? Well, it all comes down to building a more resilient sow, where that improved energy metabolism becomes an actual shield.
And this, right here, is why this all matters for a threat like African swine fever. A standard sow who's already running on a deficit, she has to shut down production just to fight an infection. The Prosea-supported sow, on the other hand, she has a surplus of bioenergy. She can afford to fuel a powerful immune response without shutting down the factory, a reproductive system. She has the energy to fight the war and keep the factory running.
And at the end of the day, this resilience pays off in a very real, tangible way. The investment in metabolic health on that Philippines farm, it delivered a calculated return of over 10 to 1, simply by turning improved energy into more weaned piglets per sow per year.
So, we'll end with this thought. In the fight against diseases like ASF, the battle isn't just fought with biosecurity gates and protocols. It's won or lost at the cellular level, inside the metabolic engine of every single sow. The real question is that engine tuned up and ready for the fight? Thanks for joining this explainer.